Welcome everyone. My name is SOŁTYSIK-PIORUNKIEWICZ. I have the great privilege to present the paper authored by Stanisław STANEK, Marian SZARY and myself, entitled The Implementation of DSS in Knowledge-Based Organizations, the New Role of Knowledge Components in DSS Meta-Design Methodology. The aim of the presentation is to show the importance of knowledge components in knowledge-based organizations in the context of DSS system implementation. The agenda of our presentation is, as you can see, divided into 5 parts. The first one is DSS meta-design methodology, then some information about DDMKCC architecture, and then the new role of knowledge component in the architecture, and the case study. At the end, we would like to conclude our research. So let's start with some principles. Since it is a natural property of knowledge that evolves continuously, a DSS that is not capable of evolving with the knowledge may not at all bring the expected benefits to the organization. Meta-design methodologies provide a higher-level abstract rules supporting the working methodology framework used in the DSS development process. In existing and sustainable systems, control function is performed via meta-knowledge subsystem like architecture, norms, axioms, and ontologies. Let's start with DSS architecture. Care must be taken to understand that the architecture does not define what DSS is. Rather, it functions as an ontology that gives a common language for design, discussion, and evaluation of DSS, regardless of the manifold variations. DSS architecture is a general framework that identifies essential elements of DSS and their interrelationships. Thanks to Power, we can show some arguments for DSS architecture. This architecture helps developers work together, improves planning, more efficient and more coordinated. This architecture increases the team's ability to implement DSS and helps other groups implement systems that must work with DSS and create ability to evaluate technology options within a context of how they will work rather than abstractly. Here we can show how this architecture connected with data, dialogue, modeling, knowledge, creativity, and communication looks like. At this slide, we can show you the architecture component of dialogue, component of modeling, component of database. On the right side of the slide, we can see the knowledge management component, the new one, which is closely connected with knowledge component, creativity component, modeling component, and we can see the dialogue component as well, with software agent and natural language processors and help systems. We can use data warehouse and application databases, intelligence extraction systems, and database components. We can show the new role of knowledge component in the architecture. Knowledge component is a well-designed DSS component, is connected to the learning process of the user. And the nature of the knowledge is that it evolving continuously. Unless the DSS is capable of evolving with knowledge, it will soon lag behind and its benefits will be lost. The development of the meta-knowledge subsystem is based on the double loop pattern of knowledge development. You can see the screen of double loop architecture. On the right side, we can see worker support subsystems and executive support subsystems, which are closely connected with meta-knowledge subsystem. The need to enhance analytics relates to the metaphor of blind surgeons, former stakeholders in a business process who perform the roles while being obvious of the prevalent trends, as opposed to knowledge workers who are increasingly aware of recent developments with data warehouse, machine learning, big data, and data lakes on hand, and empowered to revise processes as they go. Effective and intuitive human-machine dialogue is key to making the most of the available technologies, for example, of computers linked to increasingly standardized ecosystems, platforms, and supported by advanced artificial intelligence, visualizations, and augmented reality. A knowledge worker who can perform simulations employing an array of computerized models, standardized notations, for example, BPMN or UML, and software applications, for example, IBM Case Manager, is increasingly aware of the design context and capable of assessing the relative outcomes of available alternatives. Learning processes drawing on a variety of technologies, for example, business intelligence technologies, knowledge portals, etc., fuel the conversion of data into meaningful information in knowledge component, trigger knowledge development and validation, as well as the creation of meta-knowledge and parameter-based scenarios for future use. The selected case study is connected with business intelligence system implementation in Consort Company. The Consort Company is nearly 30 years on the market and is connected with consulting project and IT project in many major Polish companies. The business profile of the company is connected with designing, implementation, and oversight of IT solution, as well as business process optimization and management support services. Consort Company system draws on Microsoft technologies and products from the Microsoft SQL Server family. The knowledge workers from the company have been given the possibility of visualizing data contained in the warehouse in tabular form, exporting data to Microsoft Excel or Microsoft Word, creating advanced queries, as well as writing their own scripts in programming languages supported by the analysis services platforms. There are some limitation problems in this case study. After that, we have some results. So there are too many reports in the company. There are unrevealed facts and time lost. on digesting reports and messages. These are the key problems that most knowledge workers struggle with on an everyday basis. Is there a way to eliminate this? The research results analysis have the answer for smart reporting system implementation. A smart reporting system should be able to eliminate or mitigate at least some of the weaknesses of traditional reporting. Hence, to be able to reduce the amount of redundant information, the system must know what should be reported and how to make the data more meaningful and intelligible. In addition, it ought to be capable of tailor the visualization option to best suit each user's performances and to offer the optimum path for analysis that will engage the user in the problem rather than walk him through irrelevant facts. Finally, it might be a good idea to make sure that one report comes at the right time, bring alerts to a minimum. At the end, some conclusions. Thinking in terms of software architectures facilitates DSS development and maintenance. The extensive literature review performed, the case study conducted, and the research work involved have led the authors to advocate the thesis that the use of business intelligence systems can effectively support the development of the knowledge component in DSS environment. Future efforts should focus on the use of artificial intelligence and big data software to improve human-computer interaction in creative support, modeling, and simulation context. Researchers and developers need to further explore applicable approaches like smart systems and artificial intelligence technologies for optimum performance. Thank you very much for hearing us and see you the next conference.